Hey guys, this is Coach Lowe, and we're going to talk about Chapter 3, Section 3, which is slope. And we'll also talk about how to tell whether lines are parallel, perpendicular, or whether they just cross and there's no 90-degree angle. And we can tell all of that by the slope, so that's kind of cool. All right, so from Algebra 1, which I know has been a while for us, but from Algebra 1, when we talk about slope, there are different things that we talk about. Rate of change, rise over run, change in y over change in x, y2 minus y1 over x2 minus x1. Steepness of a line. So we know if a line is going that direction, it has positive slope, and then the steeper it is, or the more straight up and down it is, the larger the number is in front of x when we look at a line. And then the flatter it is, the closer it is to zero, to having zero slope. And we also know if the line falls as we read from left to right, it has a negative slope. Again, if it's straight across, slope is 0. Horizontal line, 0 slope, and it's always y equals that number, so hoi. Hoi. All right, and then vertical line, let me get a vertical line on there. We don't need another horizontal. Vertical line, vux. Vertical line, undefined slope, it's always x equals. So slope is undefined on this because think about skiing. You can't ski straight up and down a mountain. You can just fall, but no skiing there, and that would not be fun. Horizontal line, more like cross-country skiing. You could just run that. But those are just a recap of slope from last year. All right, reminder, if you're given 2 points, so x1, y1, x2, y2. To find the slope, we do change in y, and I draw this every time. Y's go on top, so I'll draw my arrows on top. Change in y over change in x. That's exactly how you need to write it as a fraction. It has to be written that way. Put them in that order. All is good. All right, so let's practice on one of those before we move to some other practice type problems. So let's say that we have the ordered pair 7, -3, and this is J, and that K is -8, -4. All right, and they ask me to find the slope of the segment JK, or maybe the line that goes through those 2 points. It doesn't really matter. We're going to do change in Y over change in X. Change in Y over change in X. So it will look like this. Y2 minus Y1 over X2 minus X1. Now, if you remember how to do this and you want to pause and go ahead and try this yourself, please do it. This is slope. All right, so I'm just going to follow my arrow. I started at -4 minus -3. And then I'm moving down to the bottom for my x's, and I started at -8 minus 7. All right, cleanup time. When I see 2 negatives, I can make that a positive. So now I have -4 plus 3. Opposite signs, I will subtract those numbers. -4 plus 3 is -1. And then -8 minus 7, or if you want to do plus a -7, totally fine with me, is -15. So my slope, cleaning that up, is 1/15. Very small increments. That means every time I move up 1 on my graph, I'm going right 15. Very, very flat line, almost horizontal, very flat. All right, hope that makes sense, but we'll keep going because we're going to need this to determine whether lines are parallel or perpendicular. So let's look at these two. From the picture, I can tell that they are not parallel to each other because they cross. They're also not perpendicular because I know that perpendicular lines, when they intersect, they form 4 right angles. And to me on this picture, it looks like those are not going to be 4 right angles. It looks like a couple of obtuse and then here a couple of acute. But let's go ahead and find the slopes of those lines, and then we'll talk about how we tell if they're parallel or perpendicular. So the slope of CD, first we better scrape the points off of this graph. So C, starting at the origin, is over 1 up 2. So 1, 2 for C, And for D, we're going 1, 2, 3, 4, 5 over and 4 up. So 5, 4, X first, then Y. Now we will do change in Y over change in X. If you don't know this, you need to write it every time. All right, change in Y. So 4 minus 2 over change in X. So 5 minus 1. 2/4 or 1/2. So slope of that line is 1/2. When I go up 1, I go right 2, up 1, right 2, bam, hits that point. All right, so we know that that's correct. All right, now let's find the slope of BA. All right, so A is, well, I'll start with B. It doesn't really matter. Start with B. All right, so B is over 1, up 5. So 1, 5 for B. And A is starting at the origin, left 1, down 1. So we'll go negatives on both of those. Left 1, down 1. All right, here we go. Change in Y. So -1 minus 5 over change in X. So change in Y over change in X. So -1 minus 1. All right, so -1 minus 5, same as -1 plus -5, which would be -6. -1 minus 1, same as -1 plus a -1, so that's -2. So 3 here. All right, first of all, we know the lines are not parallel. Parallel lines are parallel because they have the same slope. They never cross, they never touch. So when I find the slope of these two, if I get exactly the same number, I mean exactly, both positive, both exactly the same number, the lines are parallel. If they're perpendicular, perpendicular lines are opposite reciprocal. Opposite reciprocal. All right, in English, that means they will be opposite signs, one positive, one negative, and they will be flipped of each other. All right, so like 4 and -1/4. They're opposite signs, and if I flip 4 over 1, it's 1 over 4. The quick check on that is when I multiply these two together, the product or the answer to this multiplication will be -1 if they're perpendicular. Right? The product of the slopes will be -1. This says, yep, lines are perpendicular. All right, but you can tell by looking because they will be opposite signs and the flip of each other. All right, so first of all, these are not the same number, so they are not parallel. Second, these are not opposite signs, so we can just punt it there. They're also not reciprocals of each other. Reciprocal of 1/2 would be 2. All right, let's keep moving. All right, let's identify whether these are parallel, perpendicular, or neither, and then we'll talk about graphing. All right, so we are supposed to find the slope of MN. Wow, I just bunched those letters together and that looked awesome. All right, MN, so 0, 3, and 2, 4. Change in Y over change in X. So 4 minus 3 over 2 minus 0, and 4 minus 3 is 1, and 2 minus 0 is 2. So slope of MN is 1/2. Let's move to RS. So to be parallel, I know the slope needs to be 1/2. To be perpendicular, my slope needs to be, yeah, -2. We want to flip it over and take the opposite sign. And then if it's not 1/2 or -2, then it's an either. All right, so RS, 2, 1. And S is 8, 4. If you'd like to pause the video and do this on your own, that would be awesome. So slope for RS, change in Y. So 4 minus 1 over change in X, 8 minus 2. 4 minus 1 is 3. And 8 minus 2 is 6. So my slope reduced is 1/2. Same slope. Lines are parallel. All right, to check this on your graph, we'll totally do this in class also, but you will plot these 2 points and connect them, plot these 2 points and connect them, and see that those lines are running parallel to each other. So you could try that on your own. That'd be awesome. All right, let's do this next one. MN is -1, 3. So M is -1, 3, and N is 0, 5. So the slope for MN, change in Y, 5 minus 3, over change in X, 0 minus a negative 1, careful on those, 2 over 1, which is 2. All right, let's move to slope of RS, and we're going 2, 1, and 6, negative 1. All right, here we go. Change in Y, negative 1 minus 1 over change in X. So I have negative 1 minus 1, which is negative 2, over 6 minus 2, which is 4. That reduces to negative 1/2. All right, I needed a 2 here to be parallel. I needed a negative 1/2 to be perpendicular. These two lines are perpendicular to each other. All right, let's keep going. All right, so we are supposed to graph these and show, well, basically they're going to give you information, you're going to graph it. That's exactly what happens. All right, so let's start with the first one. Slope is 4, 1, which means rise over run. So we will start at 6, 2. You don't have to start on the y-axis. We can start anywhere. 1, 2, 3, 4, 5, 6, 2. And we will go up 4, 1, 2, 3, 4 in the positive direction. My slope is positive, and right 1. We can also go back to this point and go 1, 2, 3, 4 down and left 1. And there's my line. Whoosha! All right. So there's number 5. All right, let's look at the next one. Probably just time for one more, and that's totally fine. Passes through 8, 5. So I know I have to start at 8, 5. Perpendicular to AG. And we have A is negative 5, 6, and G is negative 1, negative 2. All right, so I know where I'm starting. I'm starting at 8, 5. All right, so there's H. I know the line has got to go through that point. I don't know the slope, but I have information here. Perpendicular, opposite, reciprocal. The slope of this line will be opposite reciprocal with AG because it's perpendicular to AG. So we're going to have to do two things. Find the slope of AG and then find the perpendicular slope because my line's perpendicular to it. So we have to find the slope of AG, flip it, change the sign. So we can do that. That's not a problem. Last one. All right. Change in Y, negative 2 minus 6 over change in X, negative 1 minus a negative 5. So top is negative 8. Bottom is positive 4. So slope is negative 2. All right. So perpendicular slope would be opposite sign, so positive. Reciprocal of 2 is 1/2. 2 over 1, flip it, 1/2. All right, so from H, I'm going to rise and run. So I'm going to go up 1, right 2. However, if I go up 1, right 2, I'm off the paper. So I'm going to go down 1, left 2. Down 1, left 2. So there's my line for number 6. Whoosha. All right, guys, hope that makes sense. On number 7, you want parallel, so we would do the same process, but we want exactly the same slope that we have here. All right, so if you graph this first line AG on number 6, you should be perpendicular to this one. All right, see you guys later. Great job. This is Coach Lowe, and I'm out.